We're going to look at some questions where there is 2 points of intersection between a straight line that is not the x-axis and a parabola, or there is just 1 point of contact, which would suggest tangency. And when there are no points of contact between the parabola and the straight line. Now, where there's 2 points of contact, as expected, the discriminant will be greater than 0. For 1 point of contact in tangency, the discriminant is equal to 0. And for no points of contact, the discriminant would be less than 0. So let's have a look at a question. We're going to prove that the line y equals 2x minus 1. We're going to prove it as a tangent to the parabola y equals x squared. Okay, so to prove tangency, we need to show that the discriminant is equal to 0. So the first thing that we do is we make y equal to y, and that will be x squared equals 2x minus 1. Bring that across to make equal to 0, so x squared will be minus 2x plus 1 will be equal to 0. A is equal to 1, b is equal to minus 2, and c is equal to 1. So that will be minus 2 squared minus 4 times 1 times 1. That will be 4 minus 1 is equal to 0, so d equals 0, therefore tangency exists. Now, if the question then asks me to find where tangency exists, I can also do that by factorisation. So two numbers that multiply give 1, add together give minus 2 is minus 1 minus 1. So that will give me a point of contact x equals 1. To find the equation, to find rather the y coordinate, I would sub it back into one of the equations of y, it doesn't matter which one, so it could be 2x minus 1 or x squared, both of which will give me the same result, which gives me 1. So the point of contact is 1, 1. Okay, next question. Prove that the line is a tangent to the parabola and find the point of contact. For y equals x minus 1 quarter and y equals x squared. So for tangent to say to exist, b squared minus 4ac would need to be equal to 0. So let's first of all make y equal to y, x squared equals x minus 1 quarter. Bring these across and that will be x squared minus x plus 1 quarter is equal to 0. Get rid of that fraction by multiplying everything through by 4, so that will be 4x squared minus 4x plus 1 is equal to 0. I can now identify a, b and c. A is 4, b is minus 4, c is equal to 1, and it's b squared minus 4ac. Minus 4 all squared minus 4 times 1, and that's 16 minus 16 is equal to 0, d equals 0, therefore tangency exists. Okay, so we now want to establish where tangency exists, so we can do so through factorisation. So two numbers that multiply give 4, add together to give minus 4 is minus 2 and minus 2. So that will be minus 2 in both brackets, drop 4x and 4x into there. I can take out a common factor of 2, and that will give me 2x minus 1 bracket 2x minus 1. 2x minus 1 all squared is equal to 0, and that will give me x equals 1/2. To then find the y coordinate of the point of contact, I'm going to sub that into one of the equations for y, doesn't matter which one, so I'm going to go for that one. So it's going to be 1/2 minus 1 quarter, which is 2 quarters, take away 1 quarter is 1 quarter. And the point of contact where tangency exists then will be 1/2, 1 quarter. Okay, another one of the same. Prove that tangency exists and find the point of contact for the straight line y equals ax minus 2 and y equals ax squared, the parabola. So make y equal to y. The condition for tangency existing will be b squared minus 4ac is equal to 0. So ax squared is equal to ax minus 2. And that will be ax squared minus ax plus 2 is equal to 0. A is equal to 8, b is equal to minus 8, and c is equal to 2. So that will be minus 8 all squared minus 4 times 8 times 2, and that's 64 minus 4 times 8 is 32 times 2 is 64. So d is equal to 0, therefore tangency exists. So again, let's establish where the tangency exists through factorisation. So I've got ax squared minus ax plus 2 is equal to 0. I can take out a common factor of 2 bracket 4x squared minus 4x plus 1 is equal to 0. And divide both sides by 2 will give me 4x squared minus 4x plus 1 is equal to 0. Okay, so factorise that. And take out a common factor of 2, brings me down to 2x minus 1 all squared. And the x coordinate at the point of contact would be 1/2. To find the y coordinate, I sub into one of the equations for y. This time I'll put it into ax squared, so 8 lots of 1/2 squared. That's 8 lots of 1 quarter. And the y coordinate is 2, so the point of contact then will be 1/2, 2. Okay, let's try one more of these types. So, prove that tangency exists and find the point of contact for the straight line y plus 8x plus 8 is equal to 0 and the parabola y equals 2x squared. So before making y equal to y, I need to rearrange this straight line equation so that it starts with y equals, but that's easy enough. So bring those across, and that will be minus 8x minus 8. It's now 2x squared equals minus 8x minus 8. And bring those across. Remember that for tangency, the condition that I'm looking for is that the discriminant is going to be equal to 0. A's 2, b's 8, and c's 8. B squared minus 4ac, so that's going to be 8 squared minus 4 times 2 times 8. And that is 4 times 2 times 8 is 64, so it's 64 take away 64, which is equal to 0. D equals 0, therefore tangency exists. So I'm now going to look to find the point of contact. So again, back to factorisation. 2 bracket x squared plus 4x plus 4. So the first rule of factorising is take out a common factor. 2 numbers that multiply give 4. Add together give 4 is 2 and 2. So that will give me 2 bracket x plus 2 all squared is equal to 0. And the point of contact will be at x equals minus 2. To find the y coordinate, sub it into one of the equations for y. So I'm going to put it into 2x squared. So 2 lots of minus 2 squared. Minus 2 squared is 4 times 2 is 8. And the point of contact where tangency exists then is minus 2, 8. Okay, we're going to go into a slightly different type question. Given its gradient, find the equation of the tangent to each parabola. So we need to find the equation of a tangent. Remember that a tangent is a straight line. So to find the equation of a straight line, it's point and gradient and into y minus b equals m bracket x minus a. So given its gradient, find the equation of the tangent to the parabola. Okay, so the parabola for the first question is y equals 2x squared plus 5. And the gradient of the tangent is 4. Okay, so remember that an equation of a straight line can be written as y equals mx plus c. Now we know that the gradient of the tangent, which is a straight line, is 4, so that can be written as 4x. We don't know the y-intercept, so we're just going to write that as k just now, as a constant that we don't know yet. So for any straight line which has got a gradient of 4, we can say that it can be written as y equals mx plus c. The gradient is 4, so 4x, and the y-intercept c we don't know it, so we could call it k. So kind of generically speaking then, it could be written as y equals 4x plus k. Just like, for example, if I said that the gradient of the tangent was 7, then generically speaking we could say that it was y equals 7x plus k. Or if the gradient of the tangent was minus 3, then the straight line could be written as minus 3 plus k in terms of its equation. Okay, so generically speaking, if the gradient is 4, the tangent has an equation y equals 4x plus k. Okay, so we can make y equal to y, 2x squared plus 5 is equal to 4x plus k. We're then going to bring everything across and make it equal to 0. 2x squared plus 5 minus 4x minus k is equal to 0. Okay, so that's 2x squared minus 4x plus 5 minus k is equal to 0. Now, since we're looking at the tangent, b squared minus 4ac is equal to 0. So that's minus 4 all squared minus 4 times a, which is 2, times c, which is 5 minus k is equal to 0. That's 16 minus 8 bracket 5 minus k is equal to 0. 16 minus 40 plus 8k is equal to 0. So that's minus 24 is equal to minus 8k. So 8k is equal to 24, and k would be equal to 24 divided by 8, which is 3. Therefore, I can now write y equals 4x plus k. Well, I know that k is 3, so the equation of the tangent can now be written as y equals 4x plus 3. Okay, let's try another. So y equals x squared plus x minus 2, and the gradient of the tangent is 1, so that can generally speaking be written as y equals mx plus c 1x plus k. So we'll make y equal to y, x squared plus x minus 2 is equal to x plus k. That'll be x squared plus x minus 2 minus x minus k is equal to 0. Those two will cancel out, and I've got x squared minus 2 minus k is equal to 0. Okay, so a is equal to 1. There's no x value, so b is equal to 0, and c is equal to minus 2 minus k. And for tangency, b squared minus 4c is equal to 0, so that's going to be 0 squared minus 4 times 1 times minus 2 minus k is equal to 0. So that's just going to be 8 plus 4k is equal to 0, and 4k will be equal to minus 8, and k is equal to minus 2. So the equation then is x minus 2, y equals x minus 2.